Truth tables. A truth table is a graphical tool used to analyze all the possible truth values of the component logical statements to determine the validity of a statement or argument along with all its possible outcomes. The rows of the table correspond to each possible outcome for the given logical statement identified at the top of each column. In the truth tables, a truth value will be represented with a capital T, a true value will be represented with a capital T, and a false value will be represented by a capital F. Example, truth value of negations. For each logical statement, determine the truth value of its negation. Part A. The statement P is defined as 3 plus 5 equals 8. Now, because 3 plus 5 does equal 8, the negation of P is considered false. So I'm going to write that not P is logically equivalent to false. Part B, the statement Q defined as all horses are Mustangs. Now because this statement is false, the negation of Q is logically equivalent to true. Part C, not R is defined as New Delhi is not the capital of India. Now I actually don't know what the capital of India is, so I'd better look that up. New Delhi is the capital of India. So this statement, New Delhi is not the capital of India, is false. So R is logically equivalent to true. Multiplication principle. How many outcomes? The multiplication principle is also known as the fundamental counting principle, and it states that the number of ways you can select an item from a group of n items and another item from a group with m items is equal to the product of m and n. So we look at each step of the process, selecting n items, selecting from a group of m items, and we multiply those two. Because each proposition P and Q has two possible outcomes, true or false, the multiplication principle states that there will be 2 times 2, which is 4, possible outcomes. So the combinations of P and Q, there are 4 of them. Those outcomes are true and true, true and false, false and true, or false and false. Now in our homework, we're going to use this order for P and Q. The first row for P and Q will be true and true, then true and false, then false and true, then false and false. A conjunction is a logical AND statement. For a conjunction to be true, both the statements that make up the conjunction must be true. If at least one of the statements is false, the AND statement is false. Notice, and both. For an AND statement, both must be true. A disjunction is a logical inclusive OR statement, which means that a disjunction is true if one or both of the statements that make it are true. The only way a logical inclusive OR statement is false is if both statements that make up the disjunction are false. Now, truth tables for these is shown on the next slide. Truth tables for and OR. So the truth table for the conjunction and is found below on the left, and it consists of 5 rows and 3 columns. The headers on those 3 columns are P, then Q, then P and Q. The first 2 rows, the column for P is true, true, false, false. The column for Q is true, false, true, false. And as stated before, the third column is only true when both P and Q are true. And so it is true, false, false, false. The truth table for the disjunction or is found below on the right. And this is a 3-column, 5-row table as well. The first 2 columns are P, Q, P and Q, and they are true, 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 false, false, true, false, false. Third column is P or Q, and as previously stated, where either P or Q is true, P or Q is true. And so the final column is true, 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 false. Truth table for not. The truth table for the negation or not is found below. Because not only acts on one operator, we have one logical statement P with truth values that are true or false, and then not P, which is the negation. So that second column is false, true. The negation of each is the swapped truth value from false to true, true to false.